Hi, welcome to today's video. This is going to be looking at what we mean when we say something is strong or weak, or something is concentrated versus dilute. Now, I'm going to be looking at it today purely from the point of view of acids, but it could just as easily be transferred over to bases because the definitions mean the same things. So first thing you need to remember, hopefully you've watched the video on what is an acid. Right? An acid is a proton donor, so you need to make sure you remember that. Okay, so what we're going to be looking at firstly is talking about the what we call the strength of an acid. So how readily an acid donates a proton is its strength. Okay, so when we're talking about something being a strong acid, okay, what we mean is it readily donates a proton. All right, so that proton, remember a proton is just the H+ ion. All acids have a hydrogen and they are donators of hydrogen ions or protons. So a strong acid readily donates H+. So what do we mean by that? Well, that means if you just simply take this acid and you perhaps put it in water, for example, what will happen is that acid will readily ionize in water, and that means it would make a lot of what we call hydronium ion. So I'm going to have a look at something like a hydrochloric acid. For example, HCl, okay? So hydrochloric acid, when we put it into water, right, this is actually what's called an equilibrium reaction. Now, I'm not going to go through what an equilibrium reaction is today, other than to say it's a reaction that can go both ways. So we show it with arrows. So in this case, I'm going to go a strong half arrow that way and a dashed arrow backwards like that. So that's showing that this reaction heavily favors the forward reaction, okay? Now, because this is a really strong acid, hydrochloric acid, what happens is that this hydrogen gets donated over to the water, and what we get is this hydronium ion, H3O+. So the water here is acting as a base, it's accepting the proton from the hydrochloric acid here, and we also end up with a chlorine ion, okay? Now, because this is a strong acid, we get lots of hydronium ion here, okay? So if you're going through and you're doing pH calculations, okay, so pH equals negative log concentration of H+, the concentration of H+ here would be quite high, all right? So the pH would be reasonably low, okay? So that's what it means by a strong acid. So it readily donates H+. A weak acid, on the other hand, okay, is something that doesn't readily donate H+, okay? So a really good example of that is something like acetic acid, okay? Acetic acid is what we call an organic acid. So it's made up of just hydrogen, carbon, and oxygen. So if we were to do up something for acetic acid instead, what we would have is, here's the formula for acetic acid. It's an organic acid, okay? When that reacts with water, okay, what our equilibrium arrows would look like would actually be looking like this. So we'd have dashed line towards the products and a solid line back towards the reactants. So what that means is that the acid here is not readily donating a proton, and it doesn't have a lot of hydronium ion being formed. Okay, so the pH for this would be a bit higher because we don't have a lot of H+ in there, and we obviously also have the acetate ion as well. So the strength of an acid or a base, all right, but the strength of an acid comes down to how readily it donates H+. Obviously, if we're talking about bases, it's how readily it accepts a H+. The stronger the acid donates that H+, the stronger the acid will be. Okay, so I'm hoping that's reasonably straightforward if you understand. Okay, but what does it mean when we're talking about concentrated versus dilute? Okay, well, always what I say for my students to remember this by is to think of cordial. Okay, so leave a comment down below what your favorite cordial is. I really like the cooler cordial, the green one. Okay, if you want to tell me what yours is, feel free. But concentrated versus dilute, okay, the easiest way to think about this is in terms of how much you've got in a certain volume, okay? So if we've got just a container like this, if this was a container that had acid in it, and pretty much all acid is always dissolved in water, okay? So if this is a container that, say, is a 1 litre container of water, if we put some acid in there, okay, if we have just a small amount of H+ in there, okay, right, that's what we call reasonably dilute. So by dilute, sorry, I'll get some new pens before the next video. By dilute, we mean there is lots of water, okay, and a small amount of acid. So a small concentration of H+. So that's what dilute means. However, if you put lots and lots and lots of H+ in, all right, this same volume, all right, but all we're doing is increasing the amount of H+ that we've got, okay. Now we have what's called a concentrated acid, which has small amounts of water and a high, need to finish my word there, sorry, high concentration of H+. Okay, so it just comes down to basically how much there is within a given solution. Okay, if you have a lot of the acid in there, it's very concentrated. If you have a small amount, it's very dilute. It's the same as if you're making cordial. If you have your glass and you fill it all the way to the top with cordial, that's really concentrated, really strong. That's not ideal. Okay, but if you only put a couple of drops in and then fill it up with water, that would be very dilute. Okay, now you can have concentrated strong acids. You can have dilute strong acids. You can have concentrated weak acids, okay? Because they're two different things. So concentrated and dilute just refers to how much of it there is per unit volume, okay? So if there's a lot of the acid present, it's concentrated. If there's not a lot present, it's dilute. But the strength of the acid, strong versus weak, comes down to how readily it donates protons. So you can have sulfuric acid, which readily donates protons. It's a very strong acid, but you've got a lot of water with it, so it's dilute. And that's what we'd use in the lab mostly. In those little dropper bottles you're using for practicals, that would be dilute dilute strong acid, okay? Whereas you can have very concentrated weak acids. So if you've got something like acetic acid or vinegar that you're using in a practical, in one of the brown bottles that we use in the fume cupboard, that's a very concentrated one, has a very strong vinegar smell to it, but it's still a weak acid. It doesn't readily donate protons. So I hope this has been fairly easy for you to follow. As always, if you've got any questions, just ask, and I'll be looking out for what your favorite cordial flavor is. Thanks, guys.